Okay, number 18. In number 18, we are dissolving hydrochloric acid, which is actually a gas in its natural state, in water. And so we'll do that. We write it as a liquid, and just about to write equilibrium arrows, but that is a strong acid. And of course, that will not only dissolve, but dissociate or ionize completely, forming a stoichiometric amount, 100% of the chloride ion that we're not really interested in, and the strong acid, H3O+. And the details on the amount of acid that we're actually bubbling in here are volume, 28.2 liters, and a pressure of 742 millimeters mercury, all at a temperature of 298 Kelvin. Okay, clearly I want to know the number of moles here. So what I'm going to do with this information is apply the ideal gas law to isolate N, and N is PV over RT. The pressure should be in atmosphere, and the volume in liter, and the temperature in Kelvin. And you know this because your gas constant units are liter, atmosphere per mole, Kelvin. So that's what directs us. So pressure, 742 millimeters mercury, and I'm just going to divide that by 760 millimeters mercury per atmosphere, and that'll take care of that conversion in unit, times a volume of 28.2 liters, and then that is times 1 over RT, so 0.08206 liter atmosphere per mole Kelvin, times 1 over, because I ran out of room here, 298 Kelvin. Okay, let's multiply that through, and we will get an answer for the number of moles of HCl, 1.126. Okay, I'm going to keep that number and not trim it back. It's stored in the calculator, and I'll use it further. So this is the amount of HCl gas that's dissolved in water, and therefore the number of moles of H3O+, or H+, if you like, that is currently now in the water is equal to this number as well, right? Because it's a strong acid. And that's really what I'm after, is the number of moles of this acid. So let's move this up over here. Now, what are we doing with this acid? We want to neutralize it by adding ammonia, NH3, and we want to know how many liters of ammonia we need to add to this solution in order to neutralize it. Well, if we want to neutralize it, we need, what do we need? We need an equivalent number of moles of my base, which in this case is NH3. Excuse me. Now, NH3 is also a gas, and they're asking us what volume will we need. So what volume is going to contain N equals 1.126 moles at a pressure of 762 millimeters mercury and a temperature of 294 Kelvin. What volume is needed? And again, we will use PV is equal to nRT. I'm going to let you work that out on your own, because this isn't a gas question per se. You should arrive at a volume equal to nRT over P, which is 27.09 liters. That's the answer you should get if you're using all of the correct units. And we'll adjust that to a correct number of sig figs, which is 3. and say that we need 27.1 liters of ammonia gas under those conditions in order to neutralize this amount of NH3 that we had up above? Great question.